So welcome everyone to the Essence of Backend Engineering. This is a multi-quarter workshop series that I'm planning that where we'll be covering all the essentials for backend engineering, and we'll be explaining like what backend is, what kind of technologies we'll be using in backend, like how backend relates to like normal software engineering, and what like some of the most modern software you'll see on like the planet will use in their backends, and kind of we'll get our hands dirty with some code and explore those technologies. So this is the first part in this series where basically we'll be covering an overview of like what backend is, what are some of the biggest technologies that are used in backend, and like how we're going to apply that through the rest of the workshop series. So let's get into that. For those of you who haven't checked in yet, this is the check-in code for the workshop. By checking in, you'll be earning membership points on ACM. And sooner or later, we're going to be rolling out an ACM store where you can redeem these points for merchandise, free merchandise. So I know how much we love free stuff, so make sure to check in. I'll give a second for people to get that. Okay, cool. So if anyone wants to follow along with these slides, that's the URL. All our URLs in ACM have the acmurl.com domain. So this one will be hack-backend-slides in case you wanted to follow along with my slides. Cool. And then for today's agenda, we're going to be going over 4 things. First, I'll be giving an overview of what this workshop series contains, like what exactly we're going to be covering. Secondly, I'll talk about what backend engineering is, since some of you might not be too familiar with the concept, and just that we're all like on the same page with what backend is. Thirdly, we're going to be diving into some of the infrastructure that today's software has with respect to backend. So this is going to include some crash courses on like the internet, HTTP, what user interfaces are, what databases are, and what APIs are. So if you aren't familiar with those concepts, that's totally fine. We're going to be explaining those in this workshop. Lastly, we're going to talk about some next steps for what the rest of the series entails. So let's dive right into the overview. Cool. So as I briefly mentioned, the Essence of Backend Engineering is a workshop series meant to provide like a practical foundation for backend engineers. So what this means is we're going to be dissecting like many modern applications to kind of understand how backend is used, or like what are the tools, what are the programming languages, what are the frameworks that are used to build backends that serve like billions of users. So we're going to be looking through like Facebook, Amazon, like Robinhood's tech stacks, and kind of understand like how are they structured and how can we use some of those technologies to build backends that are very scalable and ultimately well designed. So like I said, it's meant to be practical and beginner friendly. So if you don't have any backend experience, or if you're simply like just looking to understand what backend is, like this is the workshop series for you. If you're already familiar with backend and want to explore some other technologies, we're going to be diving like pretty deeply into some more advanced technologies like a few weeks down the road, a few months down the road. So everyone's welcome in this series. So just to highlight some concepts that we're going to be covering in this series, if you aren't familiar with any of these, that's totally fine. We're going to be diving into each of these like in very like good depth. But from the start, we're going to be talking about what HTTP is and what the internet is. So that would be like probably the most beginner friendly concept. And then we'll be diving into APIs and databases. So those top 3 we're going to be touching during this workshop, like at a very high level. We'll also potentially go a little further in depth into more advanced backend topics like caching, like containerization, and some cloud technologies like AWS, as well as some distributed systems things if people are interested in that. So some of the technologies we'll be touching are like Docker, JavaScript, Node.js, AWS, a lot of database stuff, maybe some Kafka. Like again, if you're not familiar with these technologies, totally fine, but that's kind of the range of like the scope we're going for in this series. So yeah. So that was the overview. Let's dive into what actually backend engineering is. So let's do that. So let's start off with what is a backend, because a backend is a very generic term that can be applied not only in technology, but anywhere outside of technology. So a backend simply refers to a part of any system that supports a front end. Okay, so what's a front end then? A front end is basically the part of a system that is used by a user. So this is also referred to a client, but basically the front end of any system is the part of the system that the user is interacting with, the user is like using data with, or anything that the user is really touching. So to go over a very like clear example of what a backend and what a front end is, we're going to be looking at a car. So this is a car. It's a very nice car on the beach. I don't know how it's not like stuck in the sand or anything, but this is a car. And a car is a very sophisticated system, right? Cars have been there since the 1800s, where I don't know if it was Henry Ford or someone else invented the car, but this car is a system. And like most sophisticated systems, cars will have front ends and back ends. So I'm curious, based on the definition of what I gave for a front end and back end, who can tell me what are some parts of a front end of a car? Like if I were to ask you like what's in the front end of a car, like what are some things that are part of a car that are part of its front end? Anyone like raise your hand? Yeah, what's up? Yes, steering wheel. So steering wheel is interacted by the user, like users using the steering wheel of a car like all the time. Maybe it won't be part of a front end when autonomous driving is a thing, like, but yes, it's part of the front end. Anyone else? Yeah, Garrett. Gas pedals, yes. What's your name? Raymond? Yeah, what's an example? Turn signal, yes. Anish in the back. Windows, yes. Michael. Brakes, yes. So I think you get the idea. Anything that's used by a user in the car is part of the car's front end. All right. So the car's front end includes a lot of things what people said, like steering wheel, the seats are part of the front end, like windows, like the accelerator, like the brake, the gears, they're all part of the car's front end. So what then would be part of a car's back end? Does anyone know what would be a part of the car's back end? Any guesses? Yes. Huh? Yes, the engine. I'm not too familiar with car technology, but yes, an engine would be part of a car's back end. So this is the back end of like pretty much any car you'll see. It is basically the internals of a car that aren't necessarily interacted with from the user's end, but it's very integral part of the car where there would be no car without the back end. Like without engines, without like gas tanks, without like heating, cooling mechanisms in the car, there would be no car. So every car needs a front end and a back end. Yes. So that begs the question, why do we need a back end, right? So like, why can't we just have a car where there's no separation between a front end and a back end? Like maybe the engine is in the same place as the steering wheel, and like you don't, it's not necessarily carved off like from the entire car. Well, the key to this is something called abstraction. And you might have heard this from your CS classes, but abstraction is basically separating concerns. So for example, in a car, let's say there was no distinction between a front end and a back end. That means like when you hop in your car and you sit in your chair, then the engine would be like visible to you and it would be like right next to you. And it could potentially be like modifiable by you. I know in normal cars, you can kind of modify engines if you like open the hood and start like tweaking it, but there's a good reason why a lot of the back end of a car is not accessible to you. And that's because it's simply too complicated or simply like too much info that a user doesn't need. Like when a user hops in a car, all they need is a steering wheel, a brake, accelerator. That's all they like need to interact with. And they don't necessarily need to interact with the engine or like the specifics of that. So similarly in software, like the way in which data is managed in a system internally does not need to be known by the user. All the user really cares about is the features of that software. And that's why we have front ends and back ends. Like the front end is what the user deals with. The back end is the internals of the system that make the front end actually work. So just another example, like let's say Facebook.com, like Facebook the product. Users don't really care about like how posts show up in their feed are ordered or like the algorithm that determines how the posts are shown in their feed. Like that's not very important to them. All they really care about is that there are posts on their feed, right? So that's the front end, like the posts that they see are part of the Facebook's front end. and the backend would be like Facebook's algorithm that determines how the posts are sorted, or the logic for actually like getting posts, like how posts are stored. So that's why backends are very useful. It's all about abstraction. Like abstraction in software is very, very important concept, like because it just makes things simpler. So cool. So then when we talk about front end and back end design, the ideal front end would be something that's easy to use, that's pleasing, and that's functional for users, right? Like if we think about a car, like the steering wheel should be very easy to use, the brakes should be very intuitive, because otherwise the user can't use the car or they get into an accident or something like that. And when we design backends, it's a different problem. Like when we're designing backends, what we care about is optimizing the mechanisms that serve the front end. So it's a very different challenge than what front end deals with. Front end deals with how do we make sure the user has a good experience and an interface. The back end is about how do we serve like key functionality to the front end. So that's what we'll explore like throughout this workshop. If anyone has any questions or comments, like feel free to raise your hand. So again, like I kind of gave an example, like a good front end design would be like a car, for a car example, it would be something that has like lots of capabilities like CarPlay or cruise control, and something that's pleasing to the user. Also something that's easy to use, like not cluttered with functionality. And a good backend would be something that optimizes like fuel efficiency and battery usage, all while being hidden away from the user, because that's not something the user needs to deal with. So when we talk about software, and we'll get into some like concrete examples later on, but when we talk about software, some things to think about with front ends and back ends is like, how can we separate front ends and back ends in software, right? We gave the car example, but what's a front end and what's a back end in software? Like we're going to explore that a bit. And what are some of the technologies used in a software backend? Also, we'll look into how modern software applications structure their backends, and how can we design a backend to like efficiently serve data and functionality to a front end. So these are the questions that like every backend engineer is basically answering like in their job. Wait, get some water. All right. So let's talk a little bit about backend engineering. So we talked about front ends and back ends and what they are. So just going to backend engineering, we can see that backend is simply the craft of designing and building software, like software backends, to efficiently serve a front end, right? We made that fairly clear. So as backend engineers, if any of you are like aspiring backend engineers, your role would be to choose which pieces of technology to use to create something that's reliable, efficient, and like secure for front ends, right? That's our role as backend engineers. And like I mentioned before, we're going to learn a lot about these technologies throughout the series. Cool. So let's go a little more practical into the actual infrastructure of like software we use today. So we talked about some concepts about backend. Let's dive into actual practical things. So a word on modern software. So software in today's world has like clearly seen unprecedented usage. So I pulled some statistics that are very interesting to see on like how modern software is being used. So Google, like google.com, gets used 5 to 6 billion searches per day, which if you look at the seconds, it's 60,000 per second. So like when I said that phrase, that was like 180,000 searches that were happening like right now. Likewise, Facebook has 2.89 billion monthly active users, which is roughly 37% of the world's population, which is crazy. So like we're seeing like software used in this world like has seen unprecedented usage, right? Likewise, Amazon has 200 million Prime members, which is about 2.6 of the world's population for a paid subscription. Uber gets 4 million rides a day, and Robinhood got over 750,000 requests per second during like the GameStop stock crisis shit show thing. And you'll learn about what requests are later, but yeah. So our goal as backend engineers is like, how can we build systems that are like this caliber, that can like handle 5 to 6 billion searches a day, or handle like 750,000 requests per second, right? Like what are the technologies that support this is something we're going to be looking into. So like I mentioned, like because of the demand of software, like in this world we live in, like how do we build software that is reliable and that can like actually support these systems? And that's what we're going to be answering in this question. Is that a question or discussion? Okay. Cool. So now to get a bit more technical, before we dive into actual modern systems, it's important to understand how internet actually works. And Bo Burnham would like to welcome you to the internet. So let's dive into a bit of internet crash course. And if anyone has any questions, like let me know. But yeah. Cool. So how the internet works? Well, all the internet really is just a bunch of wires. If you don't believe me, this right here is a picture of the internet. It's over 300 underground and under the ocean cables that go around the world that connect every computer to every other computer. That's the internet. And yeah, thanks for coming, everyone. That's going to be all for our workshop. We appreciate you coming. Please like and subscribe. Thank you. No, obviously not. There's a lot more sophistication behind the internet, but all the internet really is a bunch of wires. That's not a clickbait. Like that really is just the internet. But there's a lot more infrastructure that goes behind the actual internet. So let's talk some concepts here. So like I mentioned, the internet has a ton of wires, but some of the wires include DSL, cable, fiber optics, etc. So when you like have cable connected to your TV, for example, like or for your internet, like this is the type of cable you're talking about, like fiber optics. Like fiber Wi-Fi is like fiber optic wires. It's like a new technology, which is why it's so much faster than like other types of internet. So an internet service provider is a service that basically provides internet to your house, right? Like they have control over these wires and can route these wires to like this building or to your house where you can actually start like getting internet. So some ISPs include like Comcast, AT&T, like Spectrum, all the household names you're familiar with. So from these wires, the way because you can see like none of your computers you're using right now are connected to any like underground cables, right? So like how does the internet actually like get to your computer, right? Well, it gets to your computer with something called a router. So a router basically translates the data from the wires that are going underground into Wi-Fi, where your computer can then translate that Wi-Fi into actual like binary or into data, where your computer can start like sending and understanding things. So that's a very quick crash course. Just to get like a picture in your head for how the internet works. Basically, if you have your laptop right now, your laptop has like this number we're going to talk about in a sec, but that's called an IP address. But you have your computer and it's connected to a router via Wi-Fi. And this router is connected to the ISP, like we talked about, that connects to underground cables, which connects to a website. And this website's like facebook.com, but there's a whole bunch of other websites. Right, so, okay, we know about like how your computer gets internet, right? And remember, we're trying to figure out how modern systems work. So this doesn't seem like backend initially, right? You might be like kind of confused like why we're going through this, but in order to understand backend, we need to understand how the infrastructure that supports backend works. And that's kind of what we're doing here. So take a quick pause. Okay, so let's talk a little bit about IP addresses now. So every computer, like all your computers, even all your phones, like everyone's phone, has an IP address. An IP address is basically just a street address, like for your house. It's a unique ID for every computer, and it's based on geolocation. So right, like based on where you're located. So routers use IP addresses to route data from like one computer to another. So when you're on your computer and you're visiting a website, that website is hosted on another computer, and the way you access that website is your computer connects to that computer via routers, via IP addresses, and ultimately gets the data on that computer. And we'll talk about that in a bit. But yeah, for example, like Facebook's IP address is that number that's very scrambled. But yes, so when we access the internet, or when you visit a website, the data that's being transferred between these wires is something called packets. And packets basically just like they contain data regarding what you're requesting and what you're getting. So when you're requesting data, that's something like requesting a web page, like requesting some HTML, and the response is like the actual HTML. And if you don't know what HTML is, we're going to go over that in a bit too. But ultimately, the internet is like supported by this infrastructure of packet transfer. And the URL you type into your browser is something called a domain name, right? What we saw here is IP addresses, but this is the least human rootable thing ever. So people invented domain names in order to basically wrap around these IP addresses so that you don't have to type in an actual IP address into your browser. You can just type in the domain name. So a domain name would be something like acmucsd.com or google.com or something like that. And this is very specific, but a DNS is basically a phone book of domain names to IP addresses, because computers understand IP addresses, humans understand domain names. Another last couple slides on the internet. Right here, we can see like the actual data that's being transferred between like packets, across packets throughout the internet contains some HTML, CSS, and JavaScript. So what are these? So these are all files, right? They're just files on your computer that contain content that's displayed in your browser. So HTML contains the actual content, CSS contains the styling of the web page, and JavaScript's the logic. So we can go to like literally any website right now. Let me just hide this. But we can go to any website right now, right? Like members.acmucsd.com. And what we can do is we can inspect elements. So if you right click, there should be a button called inspect if you want to follow along. And basically we can inspect the source of like the website we're at, right? So this is the portal. And you can see here, there's some HTML, like you see doc type HTML, head, body, like we can expand these. We can see all kinds of HTML. If you're not familiar with HTML, like this is just disgusting. That's JavaScript. But yeah, this is all HTML that's being like translated by your browser into what's being displayed on your screen. And down here is something called CSS, where it contains like styling for the actual like website. So here you can see there's a ton of styling that the browser includes, but there's things like color, like background color, etc. That's all being sent throughout the internet, like to your computer. So that's kind of how that works. And lastly, we want to talk about a little bit about HTTP. So HTTP stands for Hypertext Transfer Protocol. And all it is just a form of communication that computers have like to talk to each other. So like humans, we use English, like I'm speaking to you in English, like computers talk to each other via HTTP. So when a computer needs data from another computer, right? So when we're visiting a website, then our computer, like my computer right here, will send an HTTP request to the other computer, and the other computer can respond with the HTML, with the CSS, with the JavaScript back to our computer. And that's just the response. So if we want to look at an example, like here's what we looked at before. But now we have actual packets being sent, right? So from your computer, if you want to visit facebook.com, like if you literally type in facebook.com into your browser, like this is what's happening under the hood. Your computer will send an HTTP request through the router, through the ISP, through the cables, all as packets, up to facebook.com, and Facebook will request the data that it's storing in its database, and we'll talk about a database later. And then in the response flow, we get the response all the way sent back through the router, through the ISP, back to the computer where the web page is displayed. So that's kind of how, like websites and like visiting the internet and like using software that you use on a daily basis on the internet, that's all kind of how it works at like a very high level. Any questions on like anything I just covered? Cool. Okay, so now let's get our hands a little bit dirtier by analyzing some of the infrastructure of like today's software. So for an example for this workshop, we're going to be using the ACM website. So we'll look at other services during like a future workshop, but to understand how software is developed and designed, we're going to be looking at the membership portal. So let's take like 2 or 3 minutes to actually see what capabilities the membership portal has, and then we'll dissect that into how it's actually structured. So I'm gonna visit the portal. This is a shameless plug, but yeah, here we have the portal. If you're not too familiar, we'll go through like a quick crash course. Here's where you check into events. You can see like upcoming events. Like this is the workshop we're at right now. So there's like events being stored. There's like points. Every user has points, right? This is my user. I can look at other users. Like I can look at my profile. I can look at the leaderboard. So I can see like all these people have so many points. But if I look at 2021, 2022, we have the current leaderboard. Shout out to anyone who's on this list who's scrolling right now. But yeah, this is like basically all the features of the portal right now. ACM Store is coming soon, TM. Don't worry about it. But yeah, that's kind of how the portal works. And like we talked about earlier, this is just a front end, right? Like this is a front end of software, and there is a back end that supports this software that we're going to kind of explore a bit. But yeah, this is the front end. And that's like the main functionality of the portal. So let's talk a little bit about front end. Just like I know we're here for back end, but we'll talk a little bit about front end just because we want to explore front end and back end to understand why back end is useful. But let's talk about user interfaces. So a user interface is simply just a medium which a user can interact with the functionality of some software. So like a front end, basically. User interface, front end, client, these are all like interchangeable words. You'll hear all three of these like in your career or like in your classes, and they all mean like essentially the same thing. So like I explained, on ACM's portal, we can attend events, earn points, like view the leaderboard, order merchandise, coming soon, I promise. And really anything the user does on the portal like involves some data. And that's true with any software we're using, right? Any meaningful software that you use has data. And the problem is like, how do we deal with that data? How do we store that data? Like, how do we use that? So another quick slide on user interfaces. We kind of already talked about this, but user interfaces are just written in HTML, CSS, and JS, and it's just loaded into your browser. Not too much detail needed here, but that's kind of how that works. So let's talk about data now, because this is the problem backend tries to solve like in our systems, right? We care about our data, we care about how we're storing data and all that kind of stuff. So for examples on data, right? Let's talk about data in general. Data can include anything, right? Anything domain specific, like stock prices, like merch items, basketball scores, YouTube videos, like emails, like anything on any software that you use like meaningfully has data, right? But at the lowest level, all data at the lowest level is just binary, right? Computers understand binary, all data is just binary. But at a level higher, we have just numbers, strings, objects, images, JSON. We'll talk about JSON in a bit, and many more. So just so that everyone understands data, some people give me an example of like what kind of data is on the portal? Like we just had a look at the portal, like I'll go back here, but like what are some examples of like data that's on this portal? Anyone? So I'll have a look, like scroll down here. We can see like there's a lot of stuff going on the portal, but I'll give one example. One example of data we have is events, right? So events are like important pieces of data because that's all like ACM is like built on right now. It's like events, right? So somewhere this data is being stored, right? And we want to figure out like where's that being stored, how's it being used? But yeah, one thing we have is events. So can anyone give me like another example? Yeah, what's that? Yeah, exactly. So we have user points, right? So when users attend events, they can gain points, right? That's like a type of logic we have in our portal, right? So user points is another data, like another piece of data. Anyone else? Right, we also have profile pictures, right? So users have profile pictures. That's not me, that's someone else. But yeah, everyone has profile pictures. Like if you scroll through the leaderboard, there's profile pictures, there's first names, there's ranks, there's all kinds of data. And as a backend engineer, we're going to be exploring how do we store this data and how do we actually use this data and like display it to the front end? Because all this data is coming from somewhere, but we just don't know where yet. So let's talk about that now. Okay, let's talk a bit about databases. So some of you might have heard the term database, like in your study or like anywhere, but let's give like a little bit formal definition of like what databases are. So all databases are just like storage units that hold data, right? So like that's the most general term of what a database is, but all databases are stored on physical hardware. So like on your computer, right? You have databases on your computer right now. Like whether you like know it or like it or not, there's tons of databases that are like existing on your computer. One example is your Google search history. So there is a database on your computer called history, like in these file paths, like you can, on your operating system, you can literally find these right now that store your Google search histories. So like when you make a search and you have like your history, like all the links you see, that's all stored on your computer, right? So all data is stored like on a computer somewhere, right? So in some cases, it's on our computer, like it's on your computer, but in other cases, it might not be necessarily on your computer, right? So let's take an example with the portal, right? We talked a bit about data regarding events like members, merchandise soon, like attendances. So I want to ask, like, is this database that holds this data located on your computer? Does anyone know? Like, any guesses? Is this on your computer? I'm seeing some no's. Okay. So yes, that's correct. This data is not stored on your computer. So then where is it stored? Any guesses? Like where would this database, like ACM's database, be stored? Like it has to exist on a computer somewhere. Any guesses? Okay. Yeah, what's up? Sure, yes. So some of you might not be familiar with AWS, but the point I'm trying to make here is that databases are always stored on a computer, but they might not necessarily be on your computer, right? They can be on someone else's computer. For in this case, ACM's portal database is in the cloud. It's on like it's on a service called Amazon Web Services that like exists like Amazon holds our data. So like Jeff Bezos has access to all our data. So that's where it's stored. But the idea is that every database is stored on a computer. And that's like a key concept when we work with databases in future workshops, right? Every database is stored on your computer, on some computer. So let's actually have a look at a database, right? We've been like very conceptual for the first part, like for part of this workshop. So let's actually look at a database, like a real database. So we're gonna look at ACM Testing Database, not our production one, but our testing database. So what's a testing database? Basically, ACM has a production, right? So production means that it's the live website that you're seeing. So like this website you're seeing is a production like ACM. That's just the term what production means. But we have our own testing instance to make sure that like the actual functionality of our app works. Like it's a place where like board members can test our own like functionality that we write, or like the developers can test that. So let's have a look at this testing database. And we'll kind of get an idea of how data is being structured. So I have an application open here called PG Admin. You don't need to be familiar at all with what this is. But basically, we are in like ACM's testing database right now. And we're going to see how data is kind of stored. So data for ACM is stored in tables. So this is called a SQL database. And we're going to talk about SQL in a future workshop because SQL databases are used by like all kinds of companies. Like I know Robinhood uses like all SQL. Google uses like a mix of SQL. But like the idea is like SQL is a type of database or a type of querying language where we can store data in like tables. So think spreadsheets, right? Like this looks like an Excel spreadsheet where we have like rows and columns basically. So we have like rows down here and like columns across. So here we have our users table. So you can see up here, You don't need to understand what any of this means. This is all SQL, but we have like a users table here. And you can see there's just a list of users, right? There's only like 8 users here. But in actual ACM, there's like 2,000 or so. There's like a lot of users. So this is how the users are actually being stored. So remember, this database is on a computer somewhere. It's like in AWS, but we are accessing it here, right? So let's have a look. So there's things we store are like emails. UUIDs are simply, it's just a unique identifier for every row so that you can distinguish rows from each other. Like let's say 2 rows have jpan@ucsd.edu and like all the fields are the same. The UUID will like have a distinction between those two. It's universally unique identifier. That's what it stands for. And you can see people can have profile pictures, first names, last names, right? You can see like I'm there, Steven's there, like there's a bunch of like board members here. We have like graduation year, major, like this is all things that you're kind of familiar with, like, but this is all on ACM's website, right? We have points, like you said, points are being stored in our database as data. We also have credits, which are used for the store when it gets released. And yeah, that's just one of the tables that we have. We can look at like events, for example. Events is something we also looked at. I can right click here, view edit data. Yeah, you can see here we have a bunch of events, right? We can look at title. So title, we have like startup intern panel, like computing at scale, like a bunch of just testing data that we have is all being stored like in this database. And this is the exact data that you'll see on the portal website. So if I like go to this website over here, like let's say I go to the testing website, which I'm not too sure what the URL is, but if I go to the testing website, I will see that exact data, right? So we have 2 components now, right? We have this user interface, which is the front end, and then we have our database, which we just showed. Right here. Any questions on like anything you see here? Cool. And just to sneak peek a little bit, you can see we have a lot of tables for ACM store. We have like merchandise, orders, users, so that's all coming soon. They're all there, but we're still rolling out the store. But that's where the data for the store is being stored. Okay, so now let's start thinking a bit more critically about backend. Because ultimately as backend devs, we need to be thinking about like, why are we using technologies that we want to be using, right? So like we have databases, we have UIs. So to talk a little bit about databases, we know that, yeah, data is stored in a database and it should be accessible and modifiable through code, right? Like the code you write on the user interface or in your backend, like they're all like code, they're all like JavaScript, Java, like TypeScript, Python, all kinds of languages. And they should be able to access data, right? Like using the database. So our question now is, how can an action in the UI update a piece of data, right? So like, let's say we have the logic of, we have a user, like one of you guys, or all of you guys, like you attended the event, right? And you all got 10 points, right? You all got 10 points for attending this event. How did that happen, right? Like that's a question we need to ask. Like, how does you attending an event, you clicking on different UI components actually update the data that's stored in our database? And more generally, how can the system on one computer interact with the system on another computer is kind of what we're looking into. So I want to have a brief discussion here to kind of understand what is the drawback of only having a UI and a database. So what do I mean by that? So right now we kind of explored 2 components, one being a user interface and one being a database. And imagine we have a world where the user interface connects directly to the database. So the UI has like full access to all the data in a database, right? What are some potential drawbacks we have here? Any like, we can start having a discussion, like what do people think are like drawbacks if we give the UI like all the access to the database, like without any kind of middleman? Yeah. Yeah, exactly. So there is no like permission level kind of set in the UI or the database. Like you, for example, could like write malicious code in the like front end to delete or update like points that I have, right? You can like remove all my points, or you can delete all the events in my database. Like there's no level of restriction here, right? Like the UI can do anything it wants in the database. So like it could just do that. Like it could just delete all my events, delete all my points, like, and now I don't have any points. I can't order any merchandise, and that's it. Or like that's just the case with ACM. But like imagine like Amazon, like if someone maliciously wrote code in the front end to delete like all the orders or like all the items that Amazon has, then like there's no more Amazon. So that's one thing. Yes, permission. Anyone else have any like what are some drawbacks if we just have a UI like having direct access to a database? So permissions is one very important thing. Anything else? Okay, so let me introduce the scenario. So right now we have an ACM website, right? We have an ACM website. It's like it's a web application. What if we want to introduce a mobile application, right? So ACM mobile application where people can like check into events and like view leaderboards on an app, like a iOS app or Android app on their phone. What's something that's kind of like a drawback if we have two UIs now connected to the database? Like, because there's a lot of ACM logic going on here. Like the point I'm trying to get at is that a lot of logic would have to be duplicated, right? So what does that mean? So let's say we have a UI that's in like a JavaScript code base, right? So we have like JavaScript, HTML, CSS. We have that code in our web application. Now let's say that we have a mobile app now that's written in like, let's say Flutter. Like Flutter is a programming language meant for developing iOS and Android apps. We would, if we don't have any middleman between the UI and the database, then all the logic we have to check attendances, increment points, like that would all have to exist in the UI and the UI code and the mobile app code, which that's a lot of duplication because the database, remember, all the database does is just store data. Like that's all it does. It's just a store for data. There's no logic in this database. It's the UI or the code that has the logic to update or like delete data from the database based on actions. So if we don't have any middleman, then we would have a lot of duplicate code between different types of UIs. And we'd also have the whole permissions issue where like any one of you can delete my data and I can't do anything about it. So the fix is something called API. So we'll take like a 2-minute break. If anyone has any questions on what I just said, like feel free to raise your hand. But we're gonna be diving into like APIs in a bit. So we'll take like a 2-minute break. If anyone needs to like stand up or anything, like feel free. I've been sitting all day. Okay, I think let's get back to the workshop here. We're almost done. Just a couple more concepts I want to highlight before we start doing technical things in the next few workshops. Appreciate everyone like handing through all these concepts because I know there's a lot of concepts here. But this is very important for understanding like why we do backend and like why we use certain technologies over others and like why backend's a thing. So it's good to like get through these concepts first. Okay, so let's talk about APIs. So an API or an application programming interface is just a toolkit. Like that's what you can think of it. It's just a toolkit, like a toolbox. What this toolbox does is it exposes functionality to any client via code. So developers can integrate with it. So what does that mean? So for now, we had a UI and a database, right? The UI like would basically do data transformations onto the database, like request data, send data. But now we're introducing something called an API, which would lie in between the UI and the database. So an API just defines a set of actions that a client can perform on its systems with constraints like permissions, like we talked about. So a couple example APIs. Let's talk about Notion's API. So for those of you who don't know Notion, Notion is like a productivity kind of app where people like can like have calendars and like you add events to calendars, you could take notes, stuff like that. So with Notion's API, you can write your own code. Like let's say you're a developer and you have your own application and you want your application to do something on Notion, right? Like let's say you have your own calendar application that you're building and you want that to reflect something on Notion's calendar. Like let's say other people on your app use Notion and you want it to update in 2 locations, then you can use Notion's API to create calendar events on Notion via code. And because normally what you would do is you would go onto Notion physically, like click a couple buttons and create an event. But an API allows you to do that via code, which is pretty cool. Likewise, Imgur, I'll actually like demo Imgur's API a bit. But Imgur, for those of you who don't know, is like an image hosting platform kind of thing. Let's look up. Yeah, so basically Imgur's API will expose all of Imgur's infrastructure via a programming interface. Okay, what does that mean? So let's take a look at images, right? So with an API, I can upload any image to Imgur without actually like clicking anything, like without going to Imgur, because normally I could go to like imgur.com and like I could upload my own stuff, right? Like I could like new post or like upload my own image. But with APIs, and don't be confused if you like we haven't covered any of this yet. This is called a REST API, like via HTTP. We will cover this in a future workshop. But the idea is that we can just visit this URL and bring that URL some data, and that'll upload a file for us, which is really cool because we don't need to do that via code. So that's why APIs are really cool. So to go over another API example, like what we just covered is like Notion, like their actual products, right? Like Notion, Imgur. Another API is just Java classes, right? Like this is the file class for Java. And this is also an API. Like it's a toolbox, right? Like a toolbox with a bunch of methods where a client, which could be us as a developer, can use this toolbox by calling its method to expose data like that it's storing, like the actual file, right? So like if I want to create a new file, like I could do file.create new file, and that could like create a new file and do its own internal work, which again is abstracted from us. Like we don't have to worry about how the file is actually created, like how the binary is like messed with in the computer. Like we don't have to worry about that. All we care about is that create new file returns a file for us and like creates a file. So that's why abstraction is really cool, because we don't really care about how create new file works. It just does it. And what this also does is that by exposing an API, we know exactly what we can do on the data, right? And this is very valuable for permissions, right? Because like we talked about earlier, like without an API, with just a UI and a database, we can do anything we want on the data. But now with an API, we know exactly what are the things we can do on the data, and that's the only thing the user can do. It can create files, it can create temporary files, it can delete files, but it can't like update a file that someone else is using, or it can't like delete all files, right? You can only delete like one file over here. There's no like delete all or anything. So we won't ever have the functionality of deleting all because the API doesn't define that for us, which is very valuable concept later on. Okay, so we just covered what APIs are. Let's talk about REST APIs. So this is a type of API, but it's basically an API over the internet. So here we looked at an example of an API as a Java class. We can also have APIs over the internet, which are what Notion and Imgur are. So the way you access them are with HTTP, which we talked about in our crash course earlier. So when we have, like how we use this API is we have a front end, right? We have the UI, and the UI has its code. It will send an HTTP request to the API with some data, and the API will respond to that client or that UI with some data as well. Like, for example, like for Imgur's API, we can go back to Imgur. Let me close this. Let's go back to Imgur. So this is an API, right? Like I can literally go to this website, and it's not working right now. All right, I guess Imgur is not working right now. That's weird. But basically, I can visit this API and upload a file, and it'll work. So that one didn't work, but let's go over another example, like ACM's portal API. So let's visit this URL, and you can see something happened. It's literally just a URL, but this is an API, right? Like this is literally just an API that we talked about. I know it's kind of hard to read, but it says not found error, the resource get API v2 is not found. Okay, so there's just, clearly the service works, or it's on, but like we haven't actually, like it's not showing anything. So if we go back to REST APIs, right? Let's actually demo one API. Let's look at event future. So I know the APIs because I've worked with these APIs before. But if we visit this URL, then you can see there's all this data, right? And what does this data look like? Oh, it's the exact same events that appear here. So here you can see Essence of Backend Engineering Part 1 overview. Here, it's just the raw data. You can see Essence of Backend Engineering Part 1 overview that is serving the front end, right? So this is like the same description that you see here. It's just here on the UI, it's like pretty and nice and colorful and excellent. But on the backend side, it's all ugly and green and quotey, and it's a mess. But this is data that a computer can understand, and this is data that a human can understand. So yeah, so we can scroll through this a little bit, right? You can see ACM Innovate has an event, building a startup team, right? These are all events, right? So here I can get all events, but let's say like I want to get like user, right? Let's say I want to get like a specific user, right? So let's say I get like user like Shruven or something, right? You can see here there's an error being thrown, right? It says missing auth token. Okay, what does that mean? So like we talked about permissions, like APIs should be like have permissions on them so that some people or some code can't access things that it's not allowed to like access. So what do I mean by that? So on our API, we have things like creating events, right? So like here, there are events on our portal. Like you should also be able to create those events. But like you can see, I'm a member, like I can't create events, right? Because only like specific members can create events on the portal, right? So what is stopping me from just creating an event? Well, it's the permissions on the API, right? Like the fact that the API like needs an auth token, which is like a token of permission that we have. Like that's why we can't actually access the API. So when we start developing APIs in our next workshops, we're going to be looking into authentication and like designing APIs so that they're like secure and like we can't access data that we shouldn't be allowed to access in the case of creating or deleting events, right? I shouldn't be able to just like walk up and delete this event, right? So that's the key takeaway. Okay, we got a couple more slides, so hang tight. But yeah, that's kind of how REST APIs work. I believe this will be our next workshop. We're going to be actually like developing an API, like developing this website, not this particular one, but we'll be like actually developing an API so that you can be able to like send the data to clients and like you can be able to request or like parse data that clients are sending to you, right? So that's what we're going to be working on as a backend dev. So just to like be real, I think about 80% of backend developers will be doing API development, like in your day-to-day job. Like I've done like a couple backend internships, and like it's all been like kind of API development, right? So like things like how do we like add a new API to be able to like maybe update events, or we have a new API where like if we create 2 events, then we could chain them together, right? Like it's all serving the logic of our front end, right? And API development is like the key to serving that logic, right? So that we hide the UI from the database and we have our own logic. So this is going to be something we're going to be diving into a lot soon. So just to reiterate everything we talked about in the last like hour, we have a UI, we have an API, we have a database, right? We have these 3 components. The UI can talk to the API via HTTP requests and responses. So if the UI needs all the events, right? Like we saw the API can provide events for the UI, then the UI can just send a request, get the events, return it, right? Likewise, if the API needs to access data, like the events are stored in this database, or let's say like we're on Amazon and the orders are stored in this database, then it would query the database, return that data, and send it back to the UI. So a standard flow, let's say like you're on Facebook.com and you like hit enter and it shows all your posts. So what would happen is we'd have the UI, it would send a request to Facebook's API to be like, yo, give me your events. And then Facebook API will be like, okay, let me get all the posts I have. And then it'll query the database, which has the posts here, return that data, and then the API will return that to the UI. And like we talked about, if we have a mobile app now, then we could have like another mobile app here that just sends data to this API, and the API is the one that stores the actual logic. And these 2 won't need to store like their own logic. All the logic will be in the API. And we'll explore that in the next workshop as well. Like actually being able to like send requests from like your phone or from your computer. Like we can do that both just on the API. Cool. Okay, that was a lot of content. I appreciate you all for like sitting through that. But let's talk about next steps, because that was a lot of concepts. Like I know you all want to get your hands dirty. So let's talk about next steps. So in the next few workshops, which we'll be starting this up in like winter quarter again, and that workshop will be on APIs. We're going to be exploring how we can design and implement like high quality APIs. So like things like permissions, what we talked about, things like getting like storing data and like retrieving data. How can we use authentication and authorization to like secure our APIs? In other workshops, we'll be exploring like data, like databases, like how to design and implement databases, like how to write SQL and like other database languages to access our data. And then how do we use more advanced technologies like containers, microservices, caches, message queues? If you don't know what that is, that's totally fine. To like further optimize our system for scaling to like ridiculously high levels of scalability. So everything here will be hands-on and practical. I know today this workshop was very conceptual, but the rest of the workshops won't be like this. Everything will be very hands-on practical, and we're going to be looking at some of the architecture that some of the common apps that you use, like Facebook, like Google, how they're actually architected, and then how do we build something like that. So like I said earlier in the workshop, this is the kind of technologies we'll be covering. We're going to be using primarily JavaScript because JavaScript is a fairly like easy language to pick up. if you're not too familiar with JavaScript, we have like hack school workshops that ACM Hack is teaching to go over JavaScript. So by the beginning of winter quarter, if you're able to like pick up some JavaScript knowledge, that would be good. Otherwise, we'll go over JavaScript in our workshops as well. But yeah, that's basically all for the workshop. I did want to point everyone to one resource before we call it a day. This is like the single greatest backend roadmap out there. So let's have a look at this. If you're interested in backend and you want to know what to learn, then this website, roadmap.sh/backend, is a giant list of concepts on like actually becoming a backend developer that like has experience and like has learned all these concepts. So we talked about like all these kind of things just now, like the internet and like basic front-end knowledge, HTML, CSS, JavaScript. We won't be going into OS because that's like so much content, and that's what CSD 120 teaches, is operating systems. We'll be learning a language, JavaScript, and then over here you can see there's all stuff about databases, right? SQL, NoSQL, APIs, caching, like unit testing, CI/CD, which we might be covering. And it all just gets way more advanced, like message brokers, containers, all that kind of stuff. So highly recommend checking out this link, roadmap.sh/backend. But if you're interested on what we're learning, a lot of our content will be like from this kind of roadmap, starting from here, from today, and going down and more down. So yeah, that's it. Thanks everyone for coming. That was very long, so I appreciate everyone for coming. But yes, welcome to Backend Engineering. Thank you.